some exam. Okay.
Is it included Viva and written both?
Yeah, that is a combined grade of your Viva and written exam. Okay. Okay. So let's start today's discussion. Our last topic was the translation or conversion of one notation into another one, isn't it?
Yes, ma'am.
Yeah. So suppose we have an arithmetic expression. So in how many ways you can represent it? There are three notation, that is infix, another is prefix notation, and the last one is postfix. For representing an arithmetic expression, we can use three notation, that is infix, prefix, and postfix. So what is infix notation? An expression is a combination of operand and operators, right? So it's just the how we can represent the operation and the operands, right? This is a representation of how the operands and operators are related with each other. So in the infix notation, we can place the operator between the operands, right? So this a plus b, this is an arithmetic expression which is represented in infix notation. Okay, so this plus operator is placed between the operands a and b. So can we convert that notation into prefix notation?
Yes, ma'am.
Prefix that place the operator before its corresponding operand, that is this plus operator is related to only two operand, one is a and another is b. So in prefix notation, the operator will be placed before these two operands a and b. What is postfix notation? Postfix, that is the operator is going to be placed at the end of the expression or after these two operand a and b. So that is postfix notation. So when an expression is represented in any of these forms or notation, we can convert it into another one. So at first we can take an expression in infix notation, then you can just try to convert it into prefix and postfix notation. So the expression is a plus b, then exponentiation d, then division e minus f plus g. So this expression is presented in infix notation, right? The operators are placed where? Between the operands. So obviously it's in infix notation. So if we want to convert it into prefix notation, prefix, that is place the operator just before the operands, right? So from where we'll start converting this expression, we know that the operator has some precedence level, right? The parentheses has the highest precedence level, and then the exponentiation, after that multiplication and division, okay, and then addition and subtraction. This is a precedence list of the operator. So here that means at first these operation will be executed because we can see two parentheses here. So at first the operation a plus b exponentiation d and e minus f will be executed. So these two operators are related with which operand? Plus or exponentiation? Obviously exponentiation. So in prefix notation, we can place this exponentiation operator between b and d. In prefix notation, this power or exponentiation operator will be placed before b and d, and now this plus operator connects two operand, one is a and another is b exponentiation d. Okay, so we can place plus before all these operands, a exponentiation b d. Okay, so we can place plus here. Then what about the second portion of the expression, e minus f? Here the operator is minus, right? So we can place it before e and f, and then the plus operator is between e minus f and g. So we can place plus here, and after that we can take the second operand g. And now this two portion of the expression is separated by a division operation. That means if we consider the whole term as x and if this whole term is y, then we can say that x is divided by y. So if it is our x and if it is y, then where we can place this division operator before all the other operands. So this is a prefix notation of the given infix notation. And in the same way, we can convert it into postfix notation. But the only difference is in postfix notation, just add the operators after the operands. So for the same expression, if we now want to convert it into postfix notation, from where we'll start? Obviously, from this parenthesis portion, right?
Yes, ma'am.
So what will be the expression now? The operator exponentiation is placed between b and d. Now we can add it after b and d because it's postfix notation. So bd then exponentiation. Now another operator is here, that is plus, and we should place it where? After this two operand. This plus connects two operand, one is a and another is b exponentiation d. So we can take our first operand a and this is our second operand. Okay, after that we can place plus. Okay, and here within the parentheses there are two operand e and f and the operator is minus. So at first we will take the operands and then we can store the operator, that is ef minus. And then this plus operator is placed between e minus f and g. So this is one operand and this is another operand which is connected with this plus operator, right? So if it is our first operand, if g is the second operand, now we are going to place the operator where? After g. So here we can write plus. And another relationship we can find here, that is a plus b exponentiation d is divided by e minus f plus g. So this is our first operand and this is the second operand. So where we can store this division operator? After all these operands. So here we can place it. Is that clear? The conversion of infix into prefix or into postfix. Hello?
Yes, madam.
Ma'am,
Yes, ma'am.
isn't
Here.
that should be ef g minus plus?
Minus plus.
I mean, the minus shouldn't be after the g.
No. At that time, the relationship will be between G and F. The operator should be placed always with its corresponding operands. And here, this minus connects the operator, operand E and F. That's why we have to place it after this two operand EF. Then we have taken G, another operand plus, which means that this plus operator can connect this operand and this operand EF minus.
Ma'am, now got it. Yeah.
Okay?
Yes.
So now we are actually discussing the data structure stack, right? So how stack helps us to convert one notation into another notation. So now we are going to use stack, which is a linear data structure for performing this operation, for converting one notation into another notation. So for this, we need an algorithm. So I'm just sharing the algorithm. Yeah, so this is the algorithm we are going to use. What is the operation name? The operation is we want to convert an infix notation into postfix notation using stack. Look at this. Now the question is different. The previous one was what we were doing. We just converted one notation into another notation, right? And we didn't mention the term stack. But here the question can be like this: convert an expression which is represented in infix notation into postfix using stack. So at that time we have to follow another strategy. So this is a way we can convert a notation into another notation. Okay, so that means an expression will be given, and that expression is given in which notation? Infix notation. So we can assume that the arithmetic expression is stored in, or we can assign a variable q where you can store all the operators and operands of the infix notation. Q is a variable which is used for storing the infix notation. Okay, so Q equals to D plus E division F minus then D division A exponentiation E then division B into C. This is our infix notation. Can you see it?
Yes, ma'am.
Yes, ma'am.
Okay, so initially you can assume that this expression can be stored in a variable and that variable can be Q. Okay, and now we'll use the data structure stack. So obviously we need a stack. Okay, and then this expression or P is the output. P is an expression which we'll get after converting the infix notation into postfix notation. So how many things are going to need here? Three things. One is the infix notation, then a stack, okay, then the expression, that is the postfix notation. So just let me write the expression here. So the expression is D plus E division F minus D again division A, then exponentiation, after that E, then division B right parentheses, after that multiplication, then C and the right parentheses. So this is our expression, and this expression is given in which notation? In infix notation. Just look at the position of the operator here. All the operators are placed between the operands, right? So this is our expression. Now we are going to assign a variable that is Q, and this variable can store the whole or all the operators and operands of the infix notation. So Q equals to D, or I can just write Q here. Okay, so now what are the other things that we need here in this operation? We need a stack. So this is our stack. Okay, and from where we can store the data in stack? From this infix notation. That means we have to scan the infix notation. After that we can store the operator or operands from this infix notation to where? Into this stack. And then we need to have a column for storing the data in which notation? In postfix notation. So that is a postfix notation, and we can use P for representing it. Is that clear? So how many columns we have here? 3 columns. One is for scanning all the data, all the characters of this infix notation. Then we need a stack for storing the operator and operands, and this is for the postfix notation. So the first step in that algorithm is, at first take a right parenthesis, and I've already added it. Add a right parenthesis at the end of the infix notation and add a left parenthesis in the beginning of the stack. What is stack? We know that stack is a data structure which has one open end, right? Suppose this is our stack. So at first we have to store a left parenthesis in the stack. And this is the first step of the algorithm. Add a right parenthesis at the end of the infix notation and add a left parenthesis at the beginning of the stack. Is that clear?
Yes, ma'am.
Okay.
Hello,
And
ma'am.
now, yes.
Ma'am, can you repeat it again?
Okay, so we are just starting the procedure. Okay, so the first step of this algorithm is this is our infix notation without the right parenthesis. Okay, this is our infix notation. So the first step is add a right parenthesis at the end of the infix notation. So this is the right parenthesis and add a left parenthesis at the beginning of the stack. And this is our stack. We just added the left parenthesis into it. Okay, now step number 2. I'm sharing that slide again. So step number 2, scan queue from left to right and repeat steps 3 to 6 for each element of queue until the stack is empty. For now, just we need to know how many times we can scan this infix notation. So how many times we're going to scan it until these right parentheses encountered or appeared. Okay, so we can start from the first element of this infix notation. If we scan this infix notation, at first we will get the data or operand D, right? When we are actually scanning this infix notation, and after the scanning process, if we got an operand, just store that operand where into the postfix notation. That is another step of the algorithm. First of all, we have to scan this infix notation. Okay, so after the first scanning, we got D, and is this operator or operand? This is an operand, right? So when the data is an operand, just store it in the postfix notation. Okay, now we'll again, and the stack has only one element, left parenthesis. After that, we will scan this infix notation again, and now we got an operator, that is plus. So when we got an operator, that operator is going to be stored in the stack. So the stack has already one element, left parenthesis. Now add plus at the top of the stack. Look at this. This is the top of the stack, right? After adding left parenthesis, how we can push another data element at the top of the stack. Okay, so here we can store the second data element plus, and the postfix notation has only one data, that is D, the operand D. Now again we will scan this infix notation, and this is a left parenthesis. Okay, so if a left parenthesis comes, just add it where at the stack. So the left parenthesis would be added at the top of the stack. So here we can store another left parenthesis, and the postfix notation will not be changed. It still has one operand D. Again we'll scan this infix notation. Now we can see that there is an operator, right? After this scanning process, we got an operand, so it will be stored where? In the postfix notation. So the postfix notation already has one operand, that is D. After D we can store E. And what about the stack? The stack will not be changed. Still it has three elements, left parenthesis, plus, and left parenthesis. Again scan the infix notation. Now we got an operator. So where we're going to place it? If division is an operator, we will store it in the stack. Stack already has three data elements. Now we are going to add it at the top of the stack. So here we can add another operator, that is division. And what about the postfix notation? It will be that is DE. Okay, after that now we got another operand, that is if. So where we can place it? The stack will not be changed, but we will place that operand where? In the postfix notation. So we can write DEF. Okay, again scan the infix notation, and the next data is an operator. that is minus. So where it's going to be placed, the minus operator.
In
Stack.
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 But there is a problem. We know that the operator has some precedence level. Parentheses is the highest one, and then the multiplication and division, after that plus and minus. This exponentiation. So look at this. In this stack, we only store the data where at the top of the stack. So when in this stack the topmost data element is division, right? And when another operator has come that is minus, we can't place it at the top of the stack because minus has a lower priority level, precedence level than the division operation, isn't it? We cannot place a lower, I mean level, lower precedence level operator at the top, where the top of the highest precedence level operator. It's not possible. This division has the highest priority level than the minus operator. So how we can place it at the top of the stack? How we can place minus at the top of the stack?
Ma'am, then how could we place the positive sign top of the parenthesis on the
Sorry, how we can?
yeah, in the first row there has a parenthesis, then a plus.
We don't need to actually think about worry about the parentheses. Parentheses, no, we don't need to worry about it. Whenever a parenthesis will come, we just add it into the stack. At that time, parenthesis has the highest precedence level, so we don't need to actually think about it. Your question is here, parenthesis has the highest precedence level, so how we can add plus, right?
Yes, ma'am.
But we are not considering the parenthesis as operator here because when we are converting this infix into postfix, we will not accept any parenthesis here.
Yes,
We
ma'am.
will not add any parenthesis in the postfix notation. We are just adding to the stack.
Yes, ma'am. Got it.
Is that clear?
Yes, ma'am.
This division operator has the highest precedence level, then minus. That's why the division should be the topmost operator, and after that we can place minus or any other lower layer operator. Okay, so what we can do now, whenever a lower level operator will come, at that time we have to pop the topmost element from the stack and we can add it where in the postfix notation. If we want to store this minus here in this stack, at first we have to pop the topmost element, that is the division operator, where we can store it. After popping it from the stack, now we can place it in the postfix notation. So DEF, then we can write division, right? The stack. After deleting it, we can store minus. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay, now we can continue the searching process or the scanning process. And now the next one is left parentheses, just add it where onto this stack. So the stack has four operator, that is parentheses plus parentheses minus, again another parentheses, and the postfix notation has four data DEF, then division. After that we got another operand, that is D. So where it's going to be stored at the end of the postfix notation. So we can write DEF, then division, again D. Okay, and the stack has the same data, that is parenthesis plus parenthesis minus another parenthesis. Okay, now the next data is an operator, isn't it? So where it will be stored? Hello? Hello?
Hello.
Can you hear? Hello?
Yes, ma'am.
Yes, ma'am. We can hear you, ma'am.
Hear me? So how many steps or how many characters you have scanned so far? the last character was D, right?
Yes, ma'am.
Okay. After that, now the next character is this division operator. So where you can store it in the expression, in the postfix expression, or in the stack. The division is an operator, so it will be stored in the stack. Okay. So look at this here. We stored the division operator, and the expression is just the same. Okay. After that, we got another operand a, so we can place it at the end of the expression. So a will be stored here. And then the next one is an operator, that is exponentiation. Now look at the stack. The topmost element of the stack is division operator, and now we are going to push another operator, exponentiation. So which has the highest precedence level, division or exponentiation?
Exponential.
Exponentiation.
Exponentiation, right? So we can easily place it in the top of the stack, right? So now exponentiation can be stored here, and this is our postfix notation. After that, the next character is E. This is an operand, so it's going to be placed at the end of the expression. So this is our expression. Now the next character is the right parenthesis. Okay, so when a right parenthesis will encounter, when it will come, then how or where we are actually going to store it? Do we need to store the right parenthesis in the stack or in the expression? No. Here we got a right parenthesis, right? So the rule is just pop all the characters from the stack until a left parenthesis comes. What is the rule? After the scanning process, if we got a right parenthesis, then pop all the operators from the stack until a left parenthesis encounters. So look at the figure now. This is the right parenthesis, and here the topmost element is exponentiation. At first we'll pop it from the stack, and then you can add it in the expression. Then the next operator will be popped out, that is the division operator, and we have added it. Okay, and then a left parenthesis has come, which means that we don't need to add any other operators here. Just remove that left parenthesis from the stack. After removing this left parenthesis, now we have how many symbols in the stack? 4 data, that is left parenthesis plus left parenthesis and minus. Okay, now again we can scan the infix notation. Okay, so here we can see an operator, that is division, and division has the highest priority level than minus, so we can place it on the stack. So this is the division operator, and after that B is an operand, so we can store it in the postfix notation. So B will be stored here, and then again a right parenthesis has come. Right parenthesis, that means pop the operators from the stack. Pop the operators from the stack. So before this left parenthesis, how many operators we have in the stack? 2 operators. At
Two.
first, topmost element, that is division operator, will be popped out, and we'll add it here. And after that, minus operator will be added. And then we can remove this left parenthesis from the stack. After removing it, now the stack has only 2 elements, that is left parenthesis and plus operator. Now the next one is an operator, that is multiplication. We can place it where? Onto this stack. So this is the next step. Now after that, C is an operand. It will be placed at the end of the postfix notation. Okay, and now the last element of the infix notation is right parenthesis, which means that again pop out all the operators from the stack. At first, this multiplication operator will be removed, and then it will be added here, and then plus will be removed. Okay, then just delete the left parenthesis from this stack. And this is the final step, and this is the output. Actually, this is the expression represented in postfix notation. Is that clear? So how many steps we needed to have in that algorithm? So Hello? Is that clear how we have converted that infix notation into postfix notation?
Yes, ma'am.
7 steps.
First,
Yes.
we just assigned a variable to that infix notation. Suppose q is an arithmetic expression written in infix, and then we can use another variable for representing the postfix expression, that is p. And the first step was push a left parenthesis onto stack and add a right parenthesis to the end of q. So this was our infix notation. We just added a right parenthesis here, and a left parenthesis is added where? In this stack. And then the next step was scan q from left to right and repeat steps 3 to 6 for each element of q until the stack is empty. So we have to repeat this scanning process for how many times we are going to repeat it? We have to continue this process for all the data elements of the infix notation. Clear?
Yes, ma'am.
And step number 3, if an operand is encountered, add it to P. So look at this figure now. Whenever we got an operand after this scanning process, we just added it where? Into this expression. That is step number 3. Then step number 4, if a left parenthesis is encountered, push it into stack. If we got a left parenthesis, suppose this one, just add it to where? Add it to the stack. Then the next step of the algorithm is if an operator is encountered, then repeatedly pop from the stack and add to p each operator which has the same precedence or higher precedence than this operator. Otherwise, add that operator to stack. So if the data element that we got after this scanning process is an operator, we can perform two different tasks. One is, suppose in the stack we have an operator such as this division operator. Okay, after that we got another operator which has the lower priority level than the topmost element of the stack. At that time, just pop the topmost element from the stack and add it to the expression, and after that we can add this operator where? Into this stack. And another rule is, suppose the operator, the topmost operator here is division. After that we got another operator which has the highest priority than this topmost element. If exponentiation has the higher precedence level than this division operation, we can simply add it to stack, because we always add the data element where at the top of the stack. Is that clear? For operator, we have two rules. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now the next step is, if right parenthesis is encountered, then repeatedly pop from stack and add to p each operator until a left parenthesis is encountered. Then remove the left parenthesis and do not add it to p. So just look at this step. So when you got a right parenthesis from this infix notation, at that time just pop all the operators from this stack until a left parenthesis comes. Okay, so when you got a left parenthesis, just remove it from the stack and don't add it to where? To this postfix notation. So in this way we can convert an infix notation into postfix notation. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, so I'm just giving you an infix notation. Try to convert it into postfix using stack. So yeah, so convert this infix notation into postfix using stack. Let's try to solve it.
Madam, done.
Okay. Done.
Yes, madam.
Okay, so Tanvir, just tell us. Yeah, I'm just writing it. Just tell us the representation or
Yes, ma'am.
the result that you
ABD.
got. Okay, I'm
Yes,
just
ma'am.
writing it here.
It's ABD plus
C
plus
plus
multiplication
then multiplication
EFG
EFG
is plus
plus
multiplication minus division.
multiplication minus division. What about the others? Is that correct result? Hello?
Ma'am, almost done. Need few seconds.
Tanvir, where is K? Okay, I'm solving it. Okay, so this is our infix notation. What is the first step? At first, we have to take a right parenthesis at the end of this infix notation, isn't it?
Yes, ma'am.
So suppose, uh, let me just create some space. So here, okay, so the first step is add a right parenthesis at the end of the infix notation, and then add a left parenthesis at the beginning of the stack. Okay, now we can start scanning this infix notation. the first element is a operand.
A.
So A will be added where? In this postfix notation. So we can add A here. After that, the next element is an operator, multiplication. So we'll store it in the stack. And this is our postfix notation with only one element A. And then we got a left parenthesis which will be added into this stack. Okay? And this is the postfix notation. And after that, we got an operand B. So that operand will be stored where? At the end of the, or at the, yeah, in the expression. And this is our stack with only 3 elements. And then the next one is an operator. So we can add it into the stack. So left parentheses, then plus, and this is our postfix notation with A and B. Now the next element is another operand, that is D, and we can place it where?
In the expression only.
In the expression.
ABD.
So ABD, that is the expression. Okay, after that, this is a right parenthesis. And what is the rules or what is the formula? If a right parenthesis comes, then pop all the operators from the stack until you got a left parenthesis. That means we can pop only one operator, that is plus. And after popping that data element, there will be only 2 elements. One is left parenthesis, another is multiplication operator. Then we can place that plus operator after D. So this is our expression ABD plus. Okay, and then the next one is an operator, that is division. Okay, so where we can store it? In the stack, or we have to pop the topmost element from the stack? Because there are 2 rules for operator. If the new operator or the precedence level of the new operator is higher than the existing one, then we have to remove the existing element from the stack. And you can see that multiplication and division both has the same precedence level. So we'll apply the rule number 1 or 2. Obviously rule number 1. Now this existing data element will be removed from the stack. Then we can place this as the topmost element of the stack. So here, after the left parenthesis, we can store division operator. Then multiplication will be stored here. ABD plus, then into. Okay. And now the next one is an operand E. So you can store it here. ABD plus multiplication E, right? And this is our stack with its precedence level is lower than this division operator. So what will happen? These operator will be removed. Okay, so after removing this operator from the stack, we can place minus or the subtraction operator. Then that division operator will be added here. Plus 2e and then division. Hello?
Yes, ma'am.
Yes, ma'am.
What is the next step? After that, we got another operand. So we can add it. So ABD plus multiplication E and division. Now the next one is multiplication operator. Multiplication has the higher priority than minus, so we can place it here, this stack, and the expression will be the same. ABD plus multiplication E division F. Okay. Now the next one is a left parenthesis, so just add it where? Into this stack. Right? Okay. After that, another operand come, that is G. So the next one will be ABD, then plus multiplication E division F, then we can add G. Isn't it?
Yes, ma'am.
Okay, so what will be the next step? In the next scanning process, we'll get an operator that is plus, isn't it? So that plus operator will be stored here. And then the next step is the next element is an operand, so we can place it here, H. And then another operator, and that is division operator. So where we can keep it, in the stack or in the expression? Obviously in the stack. Okay, and then the last data element, actually it's not the last data element, it's the last operand, it is K. So we'll place it here, and then a right parenthesis has come. So now pop all the operators from the stack. At first it will be deleted and then plus. Now we got a left parenthesis, so we can pop the data element from the stack until we got a left parenthesis, right? So now these left parentheses will be removed. Okay, after that we got another right parenthesis, again pop all the operators from here. So now we can add multiplication operator, after that minus. So this is the final step of this conversion.
Ma'am, will you repeat the last portion?
Which one?
Ma'am, the last after K.
After K. Okay, after K we have a right parenthesis. Okay, and what is the formula? If a right parenthesis comes, then delete all the operators from the stack and add them to the postfix notation. And we can pop the operators until we got a left parenthesis. So here we'll start from the topmost data element, and that is a division operator. At first we'll remove it from the stack, then we can add it here. Okay, and then the plus operator will be removed from the stack and will be added here. Now we got a left parenthesis. So we have to stop this popping function here, then just delete the parentheses from the stack. Okay, then again we have another right parenthesis. So again start deleting the data element from stack. Now the topmost data element is this multiplication operator. It will be removed first, then add it here. Okay, after that the next data element is minus. So we can add it at the end of the postfix notation, and again we found another left parenthesis, just delete it from the stack. Is it clear?
Yes, ma'am, clear.
Yes, ma'am.
Okay, so this is a way for converting the infix notation into postfix notation. So actually you have to practice it. Just take any expression, just take any operand and operator, and then try to convert one notation into another notation. Okay.
Okay, ma'am.
So in the next class we'll do the reverse opposite thing. That is, an expression will be given in postfix notation, then we will convert it into infix using the stack. That will be our next